Hello dear students, welcome to Karna Maths Academy. Today in this video, we are going to discuss one of the most important question which is frequently asked in Unseen Theorem question number 24 in SC examination. Dear students, this question is from the chapter of class 10 from area of triangles and quadrilateral. The question is ABCD is a parallelogram. ABCD is a parallelogram. E is point on AB. E is point on AB. DA and CE. DA and CE are produced to meet at P. Prove that triangle BEP is equal to triangle ADE. Dear students, once again let's look at the question. ABCD is a parallelogram. ABCD is a parallelogram. E is any point on AB. DA and CE are produced to meet at P. We have to prove that triangle BEP, that means area of triangle BEP, is equal to area of triangle AD. Dear students, already I have written given in order to save the time. We are given that ABCD is a parallelogram. E is point on AB. DA and CE are produced to meet at P, and we have to prove that triangle BEP, that means area of triangle BEP, is equal to area of triangle AD. Dear students, in order to prove area of triangle BEP equals to the area of triangle AD, we have to take a small construction, join BD. Dear students, sometimes the question is asked without figure, so let's look at the question. In this question number 24, ABCD is a parallelogram. We are given that ABCD is a parallelogram. E is point on AB. DA and CE are produced to meet at P. Prove that area of triangle BP is called area of triangle AD. So dear students, the question is given simply in words, and we have to make the diagram according to the question. So we have to make appropriate diagram according to the question. So dear students, already I have made diagram according to the question. So let's look at the proofs. Dear students, in order to prove the area of triangle ADE equal to the area of triangle BEP, at first we'll show the relation between area of triangle BCE and area of triangle BDE, because they are on the same base and between the same parallels. We know that area of triangles on the same base and between the same parallels are equal in area. So at first, in statement number 1, we write down area of triangle BC, or simply we can write triangle BC, triangle BCE. BCE is equal to triangle BD, because triangles on the same base, two triangles BC and BD, they are on the same base B. So we know that triangles on the same base and between the same parallels are equal in area. So in this statement number 1, we can write triangle BCE is equal to triangle BD. The reason is triangles on the same base and between the same parallels. Dear students, triangle BCE is contained in the triangle BCP, which contains two triangles BC and triangle BEP. So in order to show area of triangle BEP equals area of triangle AD, so we have to take the triangle which contains the triangle BEP. So dear students, in statement number 1, we have shown that triangle BCE is equal to triangle BD because they are on the same base and between the same parallels. Now in statement number 2, triangle BCP is standing on the base BC, and we have got also a parallelogram ABCD which has one side BC. So triangle BCP triangle BCP and parallelogram ABCD, they have a common base. They have the same base BC. So we know that area of triangle is half of area of parallelogram standing on the same base and between the same parallels. So dear students, in the statement number 2, we have to take triangle BCP equals to half of the area of parallelogram BCD. The reason is area of triangle is half of area of palm standing on the same base and between the same parallel. Area of palm standing on the same base, standing on the same base and between the same parallels and between the same parallels, between the same parallels. Now in the statement number 3, dear students, now in the statement number 3, now area of triangle ABD, we can write area of triangle ABD. Area of triangle ABD is equal to half of area of palm ABCD. Dear students, before taking area of triangle ABD, half of area of palm ABCD, let's take area of triangle ABD equals to area of triangle BCD, because triangle BCD and triangle ABD both are the triangles of the same parallelogram. So let's take triangle BCD equals to triangle ABD. Let's take triangle BCD. Let's take triangle BCD. BCD equals to triangle BCD equals to triangle BAD. Triangle BAD. The reason of statement number 3 is diagonal divides. BD is the diagonal, so we can say diagonal divides a palm into equal triangles. We know that diagonal divides, diagonal DIAGONL, diagonal divides a palm. The reason is diagonal divides a palm into equal triangles. A palm into equal triangles. Into equal triangles. So dear students, BD is the diagonal of parallelogram ABCD. So we can write area of triangle BCD is called area of triangle ABD, because diagonal divides a palm into equal triangles. Now area of triangle BCD we can write equal to area of triangle BCP. Area of triangle BCD. Area of triangle BCD we can directly write equal to area of triangle BCP. Now in the statement number 4, area of triangle BCD, we can write area of triangle BCD, we can write area of triangle BCP, because they are on the same base and between the same parallel lines. So area of triangle BCD we can write equals to area of triangle BCP. Area of triangle BCP, because the reason is same as statement number 1, triangles on the same base and between the same parallels. The reason for statement number 4 is same as statement number 1. Same as statement number 1. Triangles on the same base and between the same parallels are equal in area. So dear students, triangle BCD and triangle BCP are on the same base and between the same parallel lines. So we can write area of triangle BCD is equal area of triangle BCP. Dear students, now triangle BCD and triangle BCP are equal. In statement number 3, we have shown triangle BCD is equal to triangle BAD. So by combining statement 3 and 4, we get area of triangle BAD is equal to area of triangle BCP. LHS part of statement 3 and 4 are same. So we can write area of triangle BAD is equal to area of triangle BCP. So in this statement number 5, we can write triangle BC, triangle BAD is equal to triangle BCP. The reason for statement number 5 is combining statement 3 and 4. So it is from statement 3 and 4. Dear students, now in statement number 6, triangle BAD. Triangle BAD contains two triangles. One is triangle BED, another is triangle AED. So let's break down triangle BAD. Let's break down triangle BAD into two parts. Triangle BAD into two parts. Triangle BDE plus ADE. So breaking down triangle BAD into two triangles. Triangle BDE plus triangle AD. Triangle BDE plus triangle BDE plus triangle ADE equals to triangle BCP. Now triangle BCP also we can break down into triangles. Triangle BCE plus triangle BPE. Triangle BCE plus triangle BCE plus triangle BEP plus triangle BEP. So the reason of statement number 6 is from statement number 5 by using whole part exam. By statement number 5 using whole part exam. Dear students, as we know that in statement number 1, triangle BC and triangle BD are there equal, so we can cancel. So in the statement number 7, we get the proof of the theorem. That means we get triangle BEP, or we can say triangle ADE. Triangle ADE equals to triangle BEP. Triangle ADE equals to triangle BEP. So after cancelling equal triangles BD and BC on both sides, we get triangle AD is equal to triangle BEP. We get triangle AD is equal to triangle BEP, which is the proof of the theorem. So the reason of statement number 6 is number 7. The reason of statement number 7 is from statement number 6. The reason is from statement number 6. So dear students, before we end the proof of this unseen theorem, let's review the process, the method we have followed to get the proof of the unseen theorem, which is asked in group D in 5 marks in question number 24. So dear students, this question is from the chapter of area of triangles and quadrilateral from class 10. The question is very simple and it is frequently asked in SC examination. The question is ABCD is a parallelogram. ABCD is a parallelogram. E is point on AB. DA and CE are produced to meet at P, and we have to prove that area of triangle BEP is equal to area of triangle ADE. So this means the proof is very simple. So at first we have to take simple construction. The construction is join BD. So after joining BD, we get two triangles, triangle BCD and triangle BDA. So we'll show the relation of triangle AD and BP with the triangles ABC and triangle BCP. Then by using whole part exam, we get the proof. So dear students, in statement number 1, at first we take triangle BCE equals to triangle BD because they are on the same base and between the same parallels. In statement number 2, we take triangle BCP Actually, this statement is not required, so we can skip this statement number 2. So in statement number 1, we have taken triangle BCE equals to triangle BD because they are on the same base and between the same parallels. Now in statement number 3, triangle BCD, we can take triangle BCD equals to triangle BAD because diagonal BD divides palm into equal triangles. In statement number 3, now triangle BCD and triangle BCP, they are on the same base and between the same parallels. So we can write triangle BCD is equal to triangle BCP. We can write triangle BCD is equal to triangle BCP in the statement number 4. So dear students, by combining statement 3 and 4, that means in statement 3 we have got triangle BCD is equal to triangle BAD because diagonal divides a palm into equal triangles. And in statement 4 we have got triangle BCD is equals to triangle BCP. So by combining two statements, that means statement number 3 and 4, LHS part are same, so we can write RHS part also equal. So BCD is equal to triangle BAD. In statement 4 we have got same triangle BCD equal to triangle BCP. So by after combining statement 3 and 4 we get triangle BAD is equal to triangle BCP. Triangle BAD is equal to triangle BCP. So dear students, now after getting triangle BAD equals to triangle BCP, now we'll use whole part axiom. After getting triangle BAD equals to BCP, we use whole part axiom. So triangle BAD we can break down into two triangles. Triangle BAD we can break down into two triangles. Triangle BDE plus ADE. Similar triangle BCP also we can break down into two triangles, BCE plus BEP. So dear students, in statement number 6, we have simply used whole part theorem. Triangle BAD we have divided into triangle BDE plus triangle ADE. Triangle BAD we have divided into parts, triangle BDE plus triangle AD. Similarly, triangle BCP also we have divided into parts, triangle BCP. Triangle BCP contains two triangles. One is triangle BC and another is triangle BEP. So triangle BCP we have divided into two parts. First part is triangle BC and second part is triangle BEP. So in statement number 6, so we have divided triangle BAD and BCP into triangles. Triangle BD and triangle BC. Triangle BD and BC, they are equal in statement number 1. So we can cancel equal triangles on both sides of statement number 6. Then we have got triangle AD is equal to triangle BEP. We have got triangle AD is equal to triangle BEP, which is the proof of this theorem. So dear students, so the proof is very simple one. So I think you have understood the proof of this theorem. And next time again we'll meet with the next video. Dear students, if you have not subscribed our YouTube channel called Maths Academy, please subscribe it so that you'll get the regular updates of important question of SC examination. Thank you. Bye. Have a nice time.